So now from hydrostatic law you can see the hydrostatic law is dP is equal to minus of W dy. Now say we have this fluid, this is the bottom, and if we consider 2 points in it, this is point 1, this is another point 2, the distance of point 1 from bottom is y1 and distance of point 2 from bottom is y2. Pressure intensity at point 1 is say P1 and at point 2 pressure intensity is P2. Now by using this hydrostatic law you can write P2 minus P1 is equal to minus W y2 minus y1, or by rearranging the terms now you can write P1 by W plus y1 equal to P2 by W plus y2, or you can say P by W plus y is equal to constant. Okay, now by this relation you can say now the fluid which is at rest, now this term P by W plus y is constant. Now the meaning of this term, now in this term y is the elevation head, P by W is the pressure head. Now the sum of these two head, elevation head and pressure head, this we call as piezometric head. So now you can say for fluid at rest, this piezometric head remains constant. Okay. So now next we see some types of pressures or different types of pressures. The first type of pressure we have the atmospheric pressure. Now the symbol is P atmospheric. Now this is the pressure exerted by atmospheric earth. Oh sorry, this is the pressure exerted by atmospheric air on the Earth's surface. So this is the pressure exerted by atmospheric air on the Earth's surface. Now its standard value is 101.325 kilopascal, or it is also called as 1 atmospheric pressure. Okay. Now another pressure we have is the gauge pressure. Now before that we have we have the gauge pressure. We'll talk about gauge pressure first. Now as you know, we have different instruments for measuring different types of pressures. So the pressure which we measure with the help of any instrument, that we call as gauge pressure. Now in different instruments the pressure, the atmospheric pressure reading is 0. So with the help of instrument we measure the pressure which is above or below the atmospheric pressure. Okay, so the gauge pressure is the pressure above the atmospheric pressure, or it may be the pressure below the atmospheric pressure. If pressure is above or more than atmospheric, that we call as positive pressure, and if pressure is below the atmospheric pressure, that we call as vacuum. Okay. Now if we add atmospheric pressure into this gauge pressure, so if we add atmospheric pressure into the gauge pressure, so that becomes another pressure and we call it as absolute pressure. Okay, so gauge pressure plus atmospheric pressure, we call it as gauge pressure. Absolute pressure. Gauge pressure plus atmospheric pressure, we call it as absolute pressure. Now we have three more types of pressures. One we call as static pressure, another one is the dynamic pressure, and third one is the total pressure. Total pressure, this we also called as stagnation pressure. Okay, the symbol is PS, PD and PT. So now what is the difference in these three terms? Now say we have a pipeline and say some fluid is flowing through it. Now we insert here two manometric tubes, one at the wall, another one is in intermediate. Okay, something like this. Now the static pressure is the pressure exerted by the liquid or fluid flowing through this pipe on the surface of the pipe, or you can say on the wall of the pipe. Okay, so say when some liquid is flowing through this, so that liquid raises in this tube, say that is up to certain this height, and this measurement gives us the static pressure. Okay, now this pressure, static pressure, is exerted on the walls when either this fluid flowing through pipe is at rest, either this fluid is at resting condition, or moving parallel to the walls of the pipe. Okay, so in both situations you will get the value of PS. Now the second pressure we have is the total pressure or the stagnation pressure. Now this pressure is defined as the pressure that would be obtained if the fluid stream were brought to rest isentropically. Isentropically means enthalpy constant. Okay. Now if this fluid is flowing through this pipe and you brought this fluid stationary at this point at the entrance of the pipe, now what happen? When fluid coming to this pipe, the fluid raises, and at certain condition, after certain time, you see here this layer of fluid is in stationary condition or in rest. So this condition at this point, that becomes isentropic. So in this case, whatever the liquid rise, that give you the value of total pressure or stagnation pressure. Okay, now the difference between these two is our third pressure, that we call it as dynamic pressure. So dynamic pressure you can write as PT minus PS. Okay, so this is the dynamic pressure. Now this dynamic pressure, we have some other names for this dynamic pressure also. One is called velocity pressure, another name is impact pressure. Okay, now this PD is the velocity pressure. We also write it as Vs squared divided by 2G, that we call as equal to PT minus PS. Now this Vs is, or simply we call it as V squared divided by 2G. Now this V is the velocity of this flowing fluid. V is the velocity of this flowing fluid. So V squared divided by 2G, that is equal to PD, and this is equal to PT minus PS. Okay. Now this relation we use for determining the velocity of layer within a pipeline. Okay, so in your lab we have one experiment. With the help of that setup, we can measure the velocity of different layers. So accordingly we can see the velocity profile at different sections. Okay, so you can see vertically how this velocity varies. Now we have some pressure units and their conversion relation you have. So the one pressure unit we have is 1 bar. So that is equal to 10 raised to power 5 Newton per meter square, or this is equal to 100 kilopascal or equal to 750.06 mm of Hg. Another unit for pressure is 1 micron, that is equal to 10 raised to power minus 3 mm of Hg. Another unit is 1 torr, that is equal to 1 mm of Hg. Another unit is 1 microbar, that is equal to 1 dyne per centimeter square. Another unit is 1 atmosphere, that is equal to 101.325 kilopascal, or this is equal to 101.325 kilonewton per meter square. So these are few units for pressure. Okay.